Okay, in this video, we are going to go over some notes on angles of polygons, interior angle sums, and exterior angle sums theorem, and then some practice problems. So this ties into the unit. If we look at lesson 1 here, angles of polygons, our goals are to be able to calculate the sum of the interior angles of a polygon and solve problems using that theorem, and also calculate the sum of the interior angles of a polygon and use the theorem to solve problems. And this should probably read exterior angles. EXT. So we can calculate the sum of the exterior angles of a polygon and use the theorem to solve problems. That's what's up with this lesson. Okay. So angles of polygons. The sum of the interior measures of an insided convex polygon is n minus 2 times 180. And we saw that in the last video. Basically, if you look at a 4-sided figure and a 5-sided figure, you can pick up on a pattern here. If you draw a diagonal from one vertex, in the 4-sided figure, you get 2 triangles. 2 times 180 gives us 360 degrees. The sum of the angles of this quadrilateral is 360 degrees. Number of sides, take away 2 times 180 equals 360. For the pentagon, where we have 5 sides, by drawing the diagonals from one vertex, we have 3 triangles. 5 take away 2 is 3. 3 times 180 gives us 540 degrees. So 3 times 180 is 540. So that's the number of interior degrees in a pentagon based on the number of sides. So n minus 2 times 180 is our formula for the sum of the angles in a polygon based on n, the number of sides. Okay, let's look at example 1. We want to find the interior measure of each angle of the pentagon HJKLM. So altogether, these angles need to add up to 540 degrees because 5 sides take away 2 times 180 is 3 times 180, which is 540. So these angles all need to add up to 540 degrees. And we have, if we group like terms, going for the x's, 2x's, and 2x's is 4x's, 7x's, 10x's, and then looking at the numbers, we have 142 and 14. That gives us 156, and another 14, 170. So 10x plus 170 makes 540. Okay, we want to solve for x. Take 170 away from both sides. We get 370 equals 10x. We still want to solve for x. Divide both sides by 10. Knock off a 0. X is going to be 37. Find the measure of each interior angle. So we're not done yet. If x is 37, twice x is 74. Another twice x is another 74. 3 times 37 is 111. And 14 more than that gives us 125. And same thing for this other area, 125. So if we add these up, we get 250. And we got a 74 and another 74 and a 142. So we got 2 angles, 3 angles, 4 angles, 5 angles added up there. Okay, so 4, 8, 10, carry the 1, 6, 13, 20, 4, carry the 2, 2, 4, 540. These add up to 540. So we know we added these correctly. Okay, let's look at the next problem here. So in this example, we have a quadrilateral. Let's draw a diagonal. We can see that we have two triangles that are formed. 2 times 180 equals 360. So n minus 2 times 180, where n is 4, gives us 360 degrees. So these all need to add up to 360 degrees. Now we have a right angle here, that's a 90. We got a right angle there, that's a 90. We got a 3x and an x. So altogether we have 4 x's plus 180 has to equal 360. Okay, minus 180 from both sides. 4 x's is 180. Divide both sides by 4. Same as 90 over 2, which is 45 degrees. So, which is 45, so x is 45. So 3 times 45 is 135, and x itself is 45. And if we add these up, we have 180 and another 45, that's 225, and another 135 gives us 335, or 325, 355, 360. So these do sum up to 360 degrees. So it checks out. Let's look at the next one here. What's the angle measure of these angles? So let's look and see what we have. We have a 1, 2, 3. We have a pentagon. It's got 5 sides. 5 take away 2 times 180 is the interior angle theorem. 3 times 180 makes 540. So these angles, 1, 2, 3, 4, and 5. Those 5 angles all need to add up to 540 degrees. But we notice also that all these angles are congruent to each other. So if all these angles had a measure of x, we actually have 5 x's is equal to this 540 degrees. Divide both sides by 5. Each one of these angles is 108 degrees. So we can only do that because we have what we call a regular polygon. That means all the sides congruent and angles congruent. So in this case, we have a regular pentagon. So we know that we have a 5-sided figure and all the sides are congruent and all the angles are congruent. So we have 5 congruent angles and 5 congruent sides in our regular pentagon. And so we have a little bit of a modification of the formula for a regular figure. We can actually see that each angle is going to be the total sum, which is n minus 2 times 180 based on the number of sides, divided by n, which is the number of sides. And that's what each angle measures. In a regular polygon. So to find each angle in a regular polygon, it's n minus 2 times 180, which is the total number of degrees, divided by n because you have n equal angles, versus just n minus 2 times 180 to find the total number of degrees in a polygon with unequal sides, where you can't find individual side lengths without more information. Okay, so the other part that we need to learn is this polygon exterior angle theorem. And it turns out that the sum of the exterior angles, one at each vertex. Now notice this pinwheel pattern here. So we're going this way. We're kind of going in a counterclockwise direction. So angle 1, we extend that side. Extend this side, we got angle 6. Extend this side, we got angle 5. Extend angle 4. So we're kind of going always in the same direction. And extend that, we got angle 2. Well, the sum of the exterior angles, one at each vertex, sort of in the same direction as you go, all these angles add up to 360 degrees. So if you had a 100-sided polygon, the sum of all the exterior angles, one at each vertex, in a pattern, either clockwise or counterclockwise as you work around, is going to add up to 360 degrees. So let's look at example 1 here. With example 1, they want us to find the value of x. So we need to know that, well, let's look and see what we have here. So going around this way, this is an exterior angle. Going around this way, exterior angle. Going this way, exterior angle. Going this way, exterior angle. So we have 1, 2, 3, 4 sides. 1, 2, 3, 4 exterior angles. These angles need to add up to 360 degrees. So we have, looking at the x's, we have 15, we have 17 x's plus 139 equals 360. So we're going to take 139 away from both sides. We're going to get 221 equals 17x. Divide both sides by 17. Divide both sides by 17. And we get 1, 3. We get x equals 13. And all they want us to do is find the value of x, 13. For example, if we put these back in, this would be a 98, 60 would be a 78. This would be a 9 times 13, which would be a 90 plus a 27, which would be 117. This one would be a 26. And this one is 139. And if we add all these up, let's see what we get. So 139 and 26 gives us 165. And another 117 gives us 265, 275, 282. And another 78 degrees gives us 352 plus 8 gives us 360. So they sum up to 360 and it checks out. Let's look at example 2. Now the exterior angles need to add to 360 degrees. So let's find the exterior angles and mark them. So it looks like this one is going counterclockwise. There's an exterior. There's an exterior, 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 exterior. These are interior angles, so those are just there to confuse us, so we ignore those. So we have a 5-sided pentagon, 1, 2, 3, 4, 5 exterior angles. These need to add to 360 degrees. Let's see what we have. Looking at the x's, starting up here, 2 plus 5 is 7, 9, 15, 18 x's. Looking at the numbers, we have a -5, another -5, that's a -10, and that cancels out the other 10. So 18 x's is 360, divide by 18, both sides, x is going to be 20. And all we had to do is find the value of x. So again, we could put these in. It's going to be 100 degrees, this is going to be 40 degrees, this is going to be 120, take away 5, which is 115 degrees. This one's going to be 60 plus 10, it's going to be 70. And this was going to be 40, take away 5, it's going to be 35 degrees. If we add all these up, they should add up to, what, 360. Let's see. So 100 plus 35, 135. And 70 is 205. Plus 115 is 305. 320 plus another 40 makes 360 degrees. So we got that. So look at example 3. Now here we have regular exterior angles, one at each vertex. So that implies, and we could prove with a little bit of work, that this is a regular pentagon because of those equal exterior angles. Now, here's kind of like a little trick. Since all of these angles need to add up to 360 degrees, and we have 5 of them, if we let each one be x degrees, and they're all congruent, so we can use x for every one of these, 5 x's equals 360, x is 72 degrees, which is 360 divided by 5. So each one of these angles is 72 degrees. What is the measure of each of these angles? 72. 5 times 72 equals 360. So it checks out.